Good morning. It's my pleasure to join you here today. I will give you a brief summary of the keynote talk that I just gave downstairs at the Matlab Expo, and hopefully leave a lot of time for you to ask questions. The title of my talk is about the fusion and coming together of sensing, computing, communication, and control, which is transforming engineering and science. And that transformation and fusion is leading to 3 points that I want to make sure that the people attending Matlab Expo understand, which is that it's transforming industries and companies and employment in education as well. It's happening now in every traditional industry as well as new industries. And I urge the attendees to take advantage of this fusion because it creates new opportunities for all of those companies that are downstairs. So you are all in the news business, so let's look at some headlines to start. Tesla is revolutionizing the automotive industry, not just because electric vehicles, performance, or styling, but because of how they deliver their software updates over the air, whether to fix defects, or to improve performance, or to give the driver more input about the range of the vehicle. Fusing ideas from the communications industry with your smartphone with over-the-air updates now apply to automotive. In a different area, in aerospace, Google is now looking at solar drones designed to bring internet access to remote parts of the world and use that to increase the number of possible Google users. While Amazon is using drones as a delivery mechanism to deliver products to the front door of its customers without human intervention. And so aerospace is no longer the role only of NASA or European Space Agency or the Korea Aerospace Research Institute. Now you have digital marketing firms doing it as well. And beyond that, there's also change. SpaceX is a small private company that's able to deliver satellites at a fraction of the cost of the traditional spacecraft and satellite providers. And CubeSats are very small, 10 centimeter wide blocks, solar powered, that weigh about 1 kilogram. You can download instructions for how to build them over the web. It'll cost you only about $50,000 to build and deploy your own satellites. This may seem like it's just an expansion of markets, but when Google and Amazon invest in drones, they are working on controls, composite materials, solar cells, and other technologies that have an impact in industries far beyond theirs. Moving from technology to workforce, we see that Apple has more interest in automotive, perhaps to integrate their smartphones in the infotainment system of a car, or perhaps to build a car, who knows? But they are hiring more automotive engineers from companies like Mercedes in order to build their knowledge. At the same time, Ford is responding by hiring more people from places like Apple and building innovation centers right in Apple's backyard. And as was reported in the Korea Times several months ago, Apple is also looking at Samsung engineers, including battery experts, perhaps to apply to their smartphones. But interesting, battery technology is also critical to automotive applications. And so when you look at these headlines, you think about what's going on. And what's going on is a transformation being driven by the fusion of these 4 technology areas. Sensing is being able to gather data from the real world, hopefully in real time. Computing, processing that data to gain understanding and insight and knowledge. Communication, having different computing processes talk together to share context, information, or collaboration. And control, being able to respond in the real world based on what is sensed and based on the computation and communication as well. And these four technology areas all connect. Smart sensors are becoming more powerful and lower cost, while their performance is increasing. Just think about the number of sensors in your smartphone, from microphones to cameras to gyros to accelerometers, fingerprint, and so on, generating a huge amount of data. The computational platforms that can operate on that data, from low-end PCs to GPUs to server farms, up to cloud-based services such as AWS from Amazon. All of these platforms are also supported by the Mathworks products, of course. On the lower end, in embedded systems or in the nodes of the Internet of Things area, there's an increasing range of devices as well, from microcontrollers and DSPs to FPGAs to programmable SoCs from Xilinx, Altera, and other companies as well. And the goal is to very quickly design algorithms and computations to happen on these types of systems. And of course, we know that in the communication area, the change from 4G to 5G is just going to revolutionize and continue to revolutionize communication, moving us from voice transmission, text, and voicemail through to live video, streaming video, and what's going to be coming next with 5G. During the keynote talk that I gave downstairs, there in fact are particular sessions. You'll see them called out here, because that is what the attendees, the engineers and scientists at Expo really want to understand, how to do it, not simply that it can be done. And in the controls area, there are many highlights, including the Orion spacecraft. Too much noise. And this was a successful test flight of this Orion spacecraft last December. A spacecraft designed to bring humans to asteroids and perhaps even to Mars in the future. A key aspect of this is that the control systems in the spacecraft, the code was automatically generated, not handwritten, and is created using Matlab and Simulink and Mathworks tools. Automotive is one example of industries that's evolving quickly. You start to have now systems such as this, where Continental, a tier 1 supplier of automotive, is building traffic sign recognition systems, video-based, because traffic signs in the future will be dynamic, changing on road conditions, weather, traffic load, and other types of things. So autonomous vehicles will require this type of technology. So you see automotive stretching beyond control and vibration analysis to things such as machine learning, because that's needed to extract information from data. Other organizations in automotive are designing systems using video and radar, such as Delphi. Again, creating algorithms, automatically generating code, and having them run flawlessly for over a year with no bugs, with high performance. And when you add communication to the mix, you move into driver assistance systems, ADAS systems, where you're able to integrate communication between car subsystems, as well as systems with other cars, to be able to implement these types of sophisticated functionality for the driver. All of these are moving us toward the future, autonomous highway systems, which will completely transform how transportation works. But it's easy to talk about automotive and aerospace because they are technology industries. What about an area like medical devices? This is a picture of a contact lens on the eye. And right here is a sensor that measures the curvature of the eye as the person is wearing it. And it collects that information over a period of time for the doctor. Organizations are taking those types of sensors and applying computing. This organization builds systems that will help to detect irregularities in the heartbeat, and doing it using code generated from Matlab in the actual devices in the systems. It's moving into different types of packaging. This is a system that's used for asthma analysis, asthma difficulty in breathing. And they use algorithms both in a smartphone and also in the cloud, so that data can be collected on the sound of breathing, analyzed in the cloud, and the person who has the app then gets information about the occurrence of asthma attacks and the severity. No doctor needed. And when you add controls to the mix, you get into some very interesting applications. This man has lost his arms because of an electrical accident about 40 years ago. He has sensors in his body that's picking up signals from the brain that are intended to go to the arms he does not have, and he's using that to get trained to understand how he can think in order to move an arm that he doesn't have. Then you can add a prosthetic arm and connect it, and he can manage that arm just by thinking. This work has been done at Johns Hopkins University, and Matlab and Simulink were deeply used in the research and the implementation of the system. I'm going to skip a couple of these because time. Another area where computing is very important is with data, big data that may come from the Internet of Things. In each of these industries, in each of these types of systems, there's data that's being sensed, is being communicated, and is being computed so that maintenance can be planned more efficiently, to make sure that systems don't fail, to make sure it's done in a cost-effective manner. When you add control to that, then again you get very interesting transformations. Building IQ delivers a web-based service, a software as a service offering for HVAC, for heating, ventilation, and air conditioning systems, to help commercial buildings improve their energy use. They analyze big data, optimize and improve the control, and the result that they can achieve is 10 to 25% savings in total energy costs for a commercial building, a huge amount. At Mathworks, we are helping to provide tools and services for engineers who need to design these future multidisciplinary systems. One area of interesting today, because of autonomous systems, is the human-machine interface, the HMI. If you think about it, in an autonomous vehicle, the human is not really paying attention. But if there's a problem, if there's a situation, then the display must very quickly get the attention of the operator, give them a very fast status of the situation, recommended actions, and fast response to the user's decision in the case of a crisis. And so Mathworks is working with partners who build HMI systems, such as this one from the organization DISTI, connecting Matlab and Simulink to those other systems to enable the design, the testing, and the simulation of these more complex HMIs. And the goal is to create the transformational display that enables the operator to not pay attention, but then to very quickly take over when needed. In the communications area, communication is becoming an aspect of more and more systems, whether in Internet of Things, vehicle-to-vehicle communication, or other areas as well. And in the latest release of Mathworks products, which we just came out with a month or two ago, we now provide a complete set of functionality for wireless communication design, including new functionality in a variety of toolboxes as shown here. Our audience is not just those in the telecom industry, but any engineer who wants to add communication functionality to their product or service. In addition, we have a long history of testing and verification techniques used for certification and other application areas in aerospace and in automotive, in rail, industrial equipment, and so on. The attendees at Matlab Expo are gaining information not only about design, but also how to test and verify these systems, which is very important. In education, the challenge is how do they react? How do universities and students react to this type of transformation? And Mathworks has a long history of supporting education, including hands-on project-based learning, as shown in RoboCup and this quadcopter application, as well as the smart car challenge that took place and takes place in Korea every year. The goal is to create, at the end, what industry needs, which are sometimes called the T-shaped engineer. An engineer, an individual who has deep knowledge in a particular area, and also maybe more shallow but broad knowledge across disciplines, so that they can communicate and collaborate with others. Since Mathworks has customers in industry and in academia, we hear the needs of industry, which is students who are broader in their knowledge, skilled in a particular area, and able to collaborate and achieve teamwork. In other words, that T-shaped engineer. And so my goal with the keynote talk was to make sure that our customers, their managers, their strategists are thinking about how to fuse these technologies and what should they do to be able to take advantage of it. And so with that, I'd like to finish my summary of the keynote. Happy to take questions.